All right, so the last section we're going to talk about multiple angles, most specifically double angles, and then half angles. And again, if I were you, I would put this on your 3x5 card that you get to use on your test. Because once you start memorizing all this stuff, they start to look alike and become a little confusing, right? Right? Yeah, I would think so. So we're going to find the sine of 2u, or 2 theta, whatever the u happens to be. It can be all kinds of different things, right? 2x, whatever it might be. There's only one choice for sine. There's 2 choices for tangent, and it took you that long to go to get a drink of water?
No, it's not
At least he's honest. So there's 2 choices for tangent. Depending upon what you do, most likely you'll use the second choice, and you'll see what I mean when we get to some problems. But there's 3 choices for cosine. Depending upon which one you like, or what they've given you. Like if they've given me cosine, I'm going to use the middle one. Bless you. If they've given me sine, I'm going to use the bottom one. Very rarely do I use this one. I usually use one of these 2. And you'll see why in just a minute. The other thing I want to emphasize is that the sine of 2u does not equal 2 times the sine of u. You cannot take that 2 out in front of the angle measure and put it out in front of the trig function. That's not what that means. What that means is we are finding twice whatever that angle is. So if that angle is 30 degrees, we're really finding the sine of 60 degrees. But there's a little bit more to it than that. Same thing with cosine of 2u and tan of 2u. So you cannot pull that 2 out in front. Instead, what you're going to do, look at example 1. Did you get a note sheet? Okay. So for example 1, you've got 2 cosine of x plus 2 sine of 2x, your double angle, equals 0. We have to solve. I can replace the sine of 2x with a much simpler equation. If you look at what's up here, if I can replace this with all of this, I no longer have the double angle. If you want to see the derivatives of these, how they derived this equation, you can go look in Appendix A of your textbook. They're all there. I'm sure you're going to rush right to it. So I'm going to rewrite what I have. 2 cosine of x plus, and instead of sine of 2x, I'm going to put in 2 sine of x, because we're using x, cosine of x, equals 0. So all I did was rewrite what I started with. Instead of the double angle, we're putting its value in there. You taking notes, Jonathan? Now this is no different than what we have done in section 5.1 through 5.4. Right? Look at these. This is one term, and this is another term. What do the terms have in common? They have a 2, right? What else? And a cosine of x. Can't I pull a 2 cosine of x out in front of parentheses? If I divide these 2, what's anything divided by itself? 1. If I divide these 2, what's left? Just the sign, and it's positive, right? So plus sine of x. Then you're going to set each of these pieces, because these are both factors, equal to 0. So you're going to split it apart. 2 cosine of x is equal to 0. 1 plus sine of x is equal to 0. Now you're going to solve for that trig function. So for the first one, wouldn't we divide both sides by 2? And I get cosine of x is equal to 0 divided by anything is 0. That's a 0. And then here I'm just going to subtract 1, so sine of x is equal to negative 1. Both of those are either 1, negative 1, or 0, so don't both of those relate to ordered pairs in the coordinate grid? So here I have 1, 0, 0, 1, negative 1, 0, 0, negative 1, and I'm looking at 0, pi over 2, pi, and 3 pi over 2. So for the one on the left, cosine of x, is that your x value or your y value in the ordered pairs? It's your x value, right? Because remember they go cosine, sine, alphabetically. So I'm wanting to know where is the x value 0? Here and here, correct? So 2 places. And so my answers for this first one, x is equal to pi over 2 and 3 pi over 2. Then I have to look at the other one. And sine would then be my y value of the ordered pair. And I want to know when is the y value -1. Right there. So don't I have pi over 2 or 3 pi over 2 twice? So I don't have to rewrite it a second time. We already have it from the other one. So this particular one only has 2 solutions. Yes?
How do you know actually get those two reversed?
Say that louder.
How do you know those two reversed? Both side of that is the y and the side of
I memorize it by the fact that they're alphabetical.
But is that the same with
Tangent is sine over cosine. So if you had tangent of these values, I personally, if I were you, would make it into a ratio. I would put, like, if we had tangent of x is equal to 0, I would put 0 over 1, number 1. The only way for tangent to be 0, for that ratio to be 0, would be if sine, because it's sine over cosine, were 0, sine being your y value. But if you had tangent of x is equal to 1, you need to turn that into proportion, because that's going to end up being a 45, 45, 90 triangle. So you have to be careful with 1, -1, and 0 with tangent, because it's not necessarily in the ordered pairs. Spencer, does that make sense? Then? Okay. Yeah, so think alphabetically. All right, so then look at example 2. Now we are going to find sine of the double angle, cosine of the double angle, and tangent of the double angle. And all that they give you, and we've had this before, they say that the cosine of the angle, it's not the double angle, but the cosine of the angle is 5/13. And what are they doing here? It's a restriction to where? What quadrant is this? This is quadrant 4. Because cosine is positive here, right? What quadrants is cosine normally positive? 1 and 4, correct? So they're narrowing down your answers, because otherwise you'd have to have 2 answers with this. So once we get to the answers, I'm going to explain why they are the signs that they are. Okay, because we're going to find not what this angle is, but we're going to end up finding what its double angle is. Okay, and we'll get to that after we look at the answers. So the first one I'm going to start with is sine. Well, actually before that, I want to look at my quadrant. If I'm restricted to quadrant 4, I'm going to draw my triangle into quadrant 4. And here is theta. Cosine is what over what? Adjacent over hypotenuse. So adjacent to this is 5. My hypotenuse is 13. How am I going to find this? Pythagorean's theorem, or you might recognize this as a triple, but we'll go through Pythagorean's theorem. So we've got 5 squared plus b squared. The hypotenuse is 13 squared. So 25 plus b squared equals 169. Subtract the 25. B squared equals 144. Take the square root. B is equal to 12. So that 12 goes here, but it's not really 12, is it? Fourth quadrant, isn't that a -12? So we want to pay attention to our signs. The whole purpose of them restricting it into the quadrants, you have to make sure you have the correct signs on all 3 sides of that triangle. If you don't, it's going to mess up your answers for your double angles, because we're using a formula. So now that I have that information, now I'm going to find the sine of the double angle. I don't even know what the angle is, but we're going to find the sine of it. So your only choice for sine is 2 sine of theta, cosine of theta, based upon the 4th quadrant and the information that they gave you. So I have equals 2 times, instead of sine of theta, we're going to look at our picture, and isn't sine opposite over hypotenuse? Right? So I have opposite would be -12. over the hypotenuse is 13. And that makes sense because sine is negative in quadrant 4. But then I have times the cosine of theta. Well, they gave that to you, didn't they? So whether or not you had it in here correctly, you should know because they gave that one to you, is 5 over 13. And then now you're just doing the math. I'm going to put 2 over 1. And this equals, is there anything that I can cross cancel with? Vertically, diagonally? No. So 2 times 5 is 10, times the negative 12 is negative 120, divided by 13 times 13 is 169. Oddly enough, the ratio of the double angle is negative. Is sine negative in quadrant 4? Yes, so that seems reasonable. But you'll find something in a minute that won't seem reasonable. So then let's move on to cosine. So cosine of the double angle. I have 3 choices I could use. They gave me in the problem cosine. I could use sine because I just came up with it, but what if I did something wrong here? If you choose this one, you're putting in, let's say you made a mistake here, wouldn't you be putting the wrong thing into the formula? Aren't you going to get a wrong answer? In this instance, I probably wouldn't use anything that had sine in it because they gave me cosine. So I'm going to choose this one. It's your choice. You can choose any one of the 3 you want, but I'm going to choose this one because in this instance, they gave me cosine, and I want to make sure that I use the right thing. So I'm going to use 2 cosine squared theta minus 1. So I have equals 2 times, I'm going to square my cosine. My cosine they gave me was 5/13, and then minus 1. So I end up with 2 over 1 times 5 squared is 25, 13 squared is 169, minus, won't the denominator of this fraction right here, once I find the product, won't it be 169? I want to subtract 1 as a form over 169, so don't I just write 169 over 169? Now don't I have 50 minus 169? So subtract the sign of the larger would be 119, negative 119 over 169. That's the odd one. Why does that not seem to make sense to you? Cosine is negative. You're like, but it's in quadrant 4. That's the non-double angle is in quadrant 4. We'll talk about where the double angle actually is in a minute. So there's a reason why cosine is negative, because the cosine of the double angle is not actually in quadrant 4. Yes? That is reduced. Because the only thing... Actually, say that again? That shouldn't be reduced because the only thing that goes in there is 13. So 13 doesn't divide into 120. If it can be reduced, yes, you do want to, but 13 doesn't divide into 120. That's okay. It's a good question, though. All right, so then we're going to do tangent. When you find sine and cosine, I personally would be using this right here because it's the easiest one. If I'm not finding sine and cosine, I'm just doing tangent of the double angle, then I probably would do just this one. But in this case, I've already found sine of the double angle and cosine of the double angle. My only problem is I could have made a mistake with the sine, right? So you do have that issue that could occur. But I'm going to find tangent of the double angle, and I'm going to use sine of the double angle over cosine of the double angle, which in our case looks like this. Sine is negative 120 over 169, all divided by. Cosine is negative 119 over 169. When you have a fraction, don't you take the numerator exactly as it is, negative 120 over 169, and multiply it instead of dividing by the reciprocal. Negative 169 over 119 equals. Typically, you should find that your denominators cancel out. If you happen to, as Sarah had asked, what if one of these could have been reduced? I would use the unreduced version where they have the same denominators when I put it in here. And so 120 and 119 do not have anything in common, so we end up with an answer of negative 120 over 119. I'm sorry, positive. Don't we have two negatives? So isn't your answer positive? Which is also another, what? Tangent's not positive in quadrant 4. It's negative. But again, we found the tangent of the double angle. So let's think about why the signs are what they are. I'm going to actually, and you don't have to do this, but I'm just doing it to explain it to you. I'm going to show you, we can actually find out what that angle is, can't we? Can't we do the inverse cosine of 5/13? Yes or no, right? So I'm going to check my mode. I want to make sure I'm in degrees, which I am. So I'm going to take the inverse cosine of 5 divided by 13. So it's about a 67-degree angle, right? But they said that we're in quadrant 4. That's your reference angle. So really my angle goes from here all the way to here. That's not 67 degrees, right? So what that angle really is, the one that we're looking at, is 360 minus, because that's my closest, 67 degrees. We're just going to go with 67. So don't I really have 293? Right? And that is in quadrant 4, wouldn't you agree? But double that angle. So I'm going to take that angle and I'm going to double it, because that's what we're actually finding sine, cosine, and tangent of. We're finding sine, cosine, and tangent of 586 degrees. Where does that land on our quadrant, or on our coordinate grids? We have to find a coterminal angle to that. Something that's between 0 and 360. So don't I have to take away 360 from up there? I'm going to take away a full revolution. So I'm going to take away 360. Is that within our quadrant, our coordinate grid? 226. What quadrant is it in? 226. Well, this is 180. This is 270. So isn't it in quadrant 3? Which is the only one that's positive in quadrant 3? Tangent. Aren't both of those negative? Yes or no? That's why the signs turn out as they do. We're not really finding, our double angle is not really in quadrant 4. That's our single angle. If we actually found that degree, which was 67 degrees, applied it to what would be the degree in the negative quadrant, now it's really 200 and whatever it was. What'd I say it was? Oh no, 293. Then we double that. Backtrack it by finding a coterminal. So that's the reason why, if you don't care ever again, I'm just explaining to you, that's why the signs don't appear to work out with fourth quadrant. Because this is going to be important when we do our half angles too. All right, so then we have any questions on that before we flip it? You good? All right, so flip it, the back. We're using something that's really exciting. Power reducing formulas. This time we have a squared. So we've had other things where we can replace squareds with stuff, right? Like sine squared we can replace it with 1 minus cosine squared. This is just another way, another thing that we can replace sine squared, cosine squared, and tangent squared with. So let's look at example 3. Rewrite as a sum of the first powers of the cosine. And notice, here's the key here, cosine of multiple angles. Because the question is, well, how do I know when I should replace with my Pythagorean identities or when I should replace with a power reducing formula? Look at what the directions say for you to do. All of these are in terms of cosine only, correct? Right? And we want to write it as a sum of the first powers. We don't want any squared in there. If I replace cosine squared or sine squared with their equivalent Pythagorean identities, won't we still have a squared in that? Right? And so we can't use those here because we need to replace it with something that's to the first power and also something that is in cosine. And in cosine of multiple angles. They're all in cosine of double angles. That's a multiple angle. So it's just another process. So pay attention to your directions, what they're asking for. So we're going to take sine, and I'm going to replace that one with what they've suggested above. So I've got 2 over 1 times, and instead of sine, we're going to replace with 1 minus cosine of the double angle over 2. And then plus This time I'm going to replace cosine squared with this one, and we don't have anything in front of it, so just 1 plus cosine of the double angle over 2. And we do not go and replace out these double angles with what we have over here. That's not what they're asking for. They want your final answer to be in cosine of multiple angles. So you're going to leave those cosine of multiple angles alone. You're just going to combine it into one fraction. So on the first one, don't the 2's cancel out? And I'm left with 1 minus cosine of the double angle plus 1 plus cosine of the double angle. Can I cancel anything else out? The cosines canceled out, didn't they? What did I just do? So I put something in there wrong. Yeah. Oh, I forgot it over. Thank you. I knew something was off. Very nice. I'm like, what did I do? There we go. Thanks. That makes a difference, doesn't it? Okay, now I can't cancel out my cosines. However, I probably don't want to cancel out the 2's up here then, do I? Because it does not mean I have to get like denominators again. So backtrack on this one. So over here, cancel that out. So over here, I've got to multiply that 2 into the numerator. So I'm going to have 2 times 1, which is 2. 2 times the negative double angle, so I've got minus 2 cosine of 2x. It's all over 2, isn't it? Then this one I'm going to leave alone, and they're both over 2 now, so I'm just going to combine them into one fraction. So I've got plus 1 plus cosine of 2x. Now look at your numerator. I've got 2 plus 1 is, I've got like terms, right? 2 plus 1 is 3. And these are like terms. I've got minus 2 of these, but plus 1 of those. So what does that give you? Negative just cosine of the double angle over 2. I personally am fine with this because there's no trig function in the denominator. But that's not what your answer in your book is going to say. So we're going to put or. Dividing by 2, isn't that the same as multiplying by a half? Right? So your book answer is going to look like this. 1/2 times your numerator, 3 minus cosine of your double angle. And I want you to write next to this if this is your book answer. Say that loudly. To me, as long as you don't have a trig function down here, that's why I'm fine with this. Your book is going to show this as the answer, but I need you to understand that they're the same thing. I'll accept this or this, but the book's only going to say this. Usually. I think sometimes they might waffle back and forth on that. Okay, so then we're going to use the half angle formulas, which are similar theory to the double angle formulas. You're going to be given similar information as example number 2. And again, I would put these on my little 3x5 note card. So this time you're given the cosine again, but of 3/5, but you're restricted to which quadrant? Quadrant 1. And we want the sine, cosine, and tangent of all the half angles. The first thing I'm going to do is work on my restricted quadrant, which is quadrant 1. I'm going to put my my triangle in quadrant 1. Cosine is adjacent over hypotenuse. So adjacent we have 3. My hypotenuse is 5. So what's this one? 4. It's a triple. If you didn't know that, you would use Pythagoras theorem, right? And all of my signs are correct. We're all in quadrant 1. Now, when we see the signs of our half angles, we're going to go back and actually figure out what is this angle for real. And if I took half of it, where would we end up? Now think about this for this particular one. If I took half of any angle in quadrant 1, won't it still end up in quadrant 1? Right? if I take half of any angle in quadrant 2, the biggest angle you could have is 179 degrees, right? Give or take for whole units, right? So if I took 179 degrees in quadrant 2 and divided it by 2, won't I end up in quadrant 1? So the signs of my half angle should reflect the signs of quadrant 1 for sine, cosine, and tangent. Because notice that all of these formulas have a choice of plus or minus. Well, these two do. The tangent, it's going to work out. But these two have a choice of plus or minus. You have to choose the sign of the quadrant which it belongs. So we're starting in quadrant 1. Half of that angle would still be in quadrant 1. If you were restricted to quadrant 2, half of that angle would end up in quadrant 1. If you are not sure, do what I'm doing right now and go, okay, the biggest angle I can have in quadrant 2 is 179 degrees. But what if I'm in quadrant 3? What's the biggest angle I can have here? 269. Divide that by 2. Where are you going to end up? Quadrant 2, one quadrant back, right? Same thing's going to happen here. The biggest angle I could have is 359 degrees. Divided by 2, where do you end up? That one's a little close, isn't it? Let's do 358. Where do you end up? 179. You end up in quadrant 2, don't you? So that's going to reflect, on your homework tonight, where you end up. So you have to be careful. I personally would check to see what is that really. Make sure that that reference angle does occur in that quadrant, and then take half of it and see what quadrant you actually end up in, and that'll tell you for sine and cosine whether you choose a positive or negative value. For this particular example, won't we be choosing positive values no matter what? Why? Because I start in quadrant 1, any angle in quadrant 1, if I take half of it, it's going to end up in quadrant 1. Aren't all sine, cosine, and tangent positive in quadrant 1? It's not the case once you hit quadrant 2, 3, and 4. So be careful. All right, so we're going to use sine. We'll start off there. So I've got sine of my half angle is equal to, don't drop off your square root. So I'm going to do plus. So I'm specifically choosing plus because of what we just talked about. So unlike what we did over here, this works out without you having to think about it. This one you have to think about for the half angles. And you might want to highlight this. The signs of your half angle for sine and cosine depends upon the quadrant in which that half angle ends up lying. So that's why I choose plus. Then I've got 1 minus. What's the cosine of this angle? They gave it to us, right? Even so, you can look at your triangle, 3/5 divided by 2. Isn't 1 5/5? Right? And so 5 minus 3 gives me the square root of 2/5 over 2. That 2 is really 2 over 1, isn't it? The reason for that is that we've got the square root of 2/5 times, take the reciprocal, 1 over 2. My 2's cancel, and I get the square root of 1 over 5. Can I have a fraction under the radical? Can I? No. What's the square root of 1? 1. And I can't take the square root of 5. Can I have a radical in the denominator? No. You do have to rationalize. So rad 5 over rad 5. So your final answer is square root of 5 over just 5. And it is positive because our half angle does end up being in quadrant 1. The only time that your restricted quadrant and your half angle end up in the same quadrant is when it's restricted to quadrant 1. They will end up in the same place. Yes?
So if the triangle is in quadrant 3 and 4, you would put a negative square root instead?
Correct. Well, okay, yes. And especially with quadrant 4, I'm going to double check. I will always double check and see, because I can take the inverse sine of this, right? Or the inverse cosine of this, to find out what that angle actually is. Because I could have given you this, well, I gave you a positive one. If I were going to be in these two quadrants, would you give me a negative one, right? If I restricted to those two, so do pay attention to that as well. But that'll give you your reference angle, not necessarily the angle that we're talking about. So if you know you're in quadrant 2, but your reference angle turns out to be 37 degrees, you have to take 180 minus 37 degrees. That's the angle that we're looking at, and then you take half of that angle, not half of the 37 degrees. Does that make sense? And double check where you're at. Usually, I mean, in quadrant 2, you're going to end up in quadrant 1. Quadrant 3, most likely quadrant 2. But quadrant 4, you could end up in 2 or 3. Probably 3. But that's one's weird. All right, so then look at your cosine. Cosine of the half angle, oops, we are doing u, equals square root. And again, I'm choosing positive, not negative. 1 plus, the only difference between the first one and this one is we have a plus versus a minus, the 3/5 over 2. So again, I'm going to change this 1 to a 5/5. So I get square root of 5 plus 3 is 8/5 divided by 2, and I'm going to put that 2 over 1. Take the numerator, multiply it by the reciprocal. If I were you, I would reduce if I can. So 2 goes into 2 and 8, 1 and 4 times. And then what's the square root of 4? 2 over, we cannot take the square root of 5, so it's radical 5. Rationalize. Rad 5, 5, and we get 2 rad 5 over just 5. And again, that's positive. Then for tangent, you have a choice. You can use this one or this one. They're both about the same, right? I probably would choose this one because there's no subtraction. So I'm going to do tangent of my half angle is equal to, and notice that they don't give you a choice on tangent because on tangent your sine's going to work out however it's supposed to work out. So sine of u, so my sine is 4/5, so we haven't used sine yet, but it's opposite over hypotenuse, divided by 1 plus my cosine, which is 3/5. So again, I'm going to change that 1 to 5 over 5. There's no square root on this one. So I get 4/5 divided by 8/5, which equals 4/5 times the reciprocal 5/8. The 5's cancel. The 4 cancels into 4 once and into 8 twice. So we end up with an answer of 1/2. So you've got 3 problems that you're going to practice today.